Okay, here is another friction problem. Again, I'm going to start by drawing a diagram. So I have my block, which is 90 kilograms. Here's the floor. We know it has a weight of 900 newtons, using 10 for G here. It's going to be supported with the normal force of 900 newtons because we're not in an elevator, nothing else is pushing on it, it's not falling through the floor. We are applying a force of 300 newtons. And according to the problem, it looks like there's some friction, but we don't know how much yet. And we know it does accelerate at 2.1 meters per second squared, and we're going to assume that's forward in the same direction. So our goal is to find the coefficient of friction. If you recall, we know that the force of friction is equal to the coefficient of friction times the normal force. Well, we know the normal force here is 900 newtons, so that's known. So we're looking for this, so the only way to do that is to find the force of friction. So how do we go about doing that? Well, we know the acceleration of the block, and we know the mass of the block. So with that information, we should be able to calculate the net force on the block using the second law. So the second law says net force is mass times acceleration. So the mass of the block is 90 kilograms. The acceleration is 2.1. So if I multiply those out, 90 times 2.1, I get 189 newtons. So that means that the net force on this block is 189 newtons. So I'll draw that, the separate arrow to the right. So I am applying a force of 300 newtons. Friction is pushing against me, and I get a net force of 189. So what is the force of friction that will accomplish this? So it's basically the difference between 300 and 189. So if I take that difference, I get 111 newtons. So 111 newtons opposes the 300 newtons, giving you a net force of 189. So now I can take this force of friction and plug it into this equation. 111 newtons is the force of friction. I don't know mu, but I know the normal force was 900. So then I can divide both sides by 900 and get that 111 divided by 900 is mu, which is 0.12, and I'm just going to round that off. It's 123, but I'm going to round it to 0.12. So that is the coefficient of friction for this problem. So I had to work backwards there, but just important to ask yourself what you know, and just kind of say, all right, what do I need to get that? And chances are you're going to have some way of getting that information. So that is another friction problem. So until next time, I am Derek Genova. Have a delightful day.